Guys, let's do our first example for composite areas. We've got this area shown here, and we want to find the moment of inertia about the x prime axis. The x prime axis is right here. It's going through the centroid of the entire area. So what we want to do is find the ix prime value. Now, before we get started, remember we had this drawing here. We had the centroid of our area, and then we have all of these distances. Okay, so dx and dy, those are measuring from the axis we're interested in to the centroid of the area. Okay, so keep that thought in mind. Now, in order to do this problem, what we need to do first is we need to have the centroid of the whole area. So I'm just going to give you that value instead of solving it. But this says y prime or y bar. I know it's kind of small here, but if you went through and found the centroid using composite bodies, you would get that y bar is 154.4 millimeters. And we're going to need this to find the moment of inertia. Okay. Now this problem, obviously you don't need to integrate because we can split this up into three very simple shapes. We have a rectangle, another rectangle, and then we have this circle. So we're going to split it up, and then we're going to calculate ix prime. And remember from parallel axis theorem, we're going to have ix bar plus a dy squared. All right, so that's what we're going to have. Now let's go ahead and create our table. We're going to have region, we'll have area, and I need dy, then I need the area times dy squared, and then we need this term right here. So let's call this I bar, and if you want, you could still call this x prime. Now, this x prime is the x prime for the centroidal axis of each shape, so don't get it confused with this x prime here. All right, so if it's easier for you, you might want to leave it off. Okay. Let's make a note. This is the x centroidal axis for each region. All right. Okay, so let's get started. First, we're going to have this region up here. So let's draw out the shape, and it's 15 millimeters by 150 millimeters. Now let's go ahead and find the area for that. This is a rectangle, so we just need to multiply these together. So you'll have 15 times 150. That gives you 2,250. Right, so now we have that. Now what we need to do is find dy. Okay, so think about what dy is. And let's see. We'll try to draw it up here. dy, if we go back, let's go back to this picture. Let's say our area now is this rectangle. Okay, so forget about this shape here. Think about the rectangle. dy is the distance from the axis we're concerned with, which for us is the x prime axis. So we want to go from that x prime axis up to the centroid of our rectangle. All right, that means we want to go from here up to here. So let's label this one. This is the centroid location for this rectangle. So it's got an axis here. And what we want to do is we want to find this distance from here to here. All right. Now, if this is 15 millimeters, we know then that this distance here has to be 7.5. All right. So that means that this is 7.5. Now we can find this distance. So we're going to have the 154.4 minus 7.5. like that. And that gives us 146.9. So all you're trying to do is you're looking at the axis you're concerned with. So we wanted x prime. That's the moment of inertia we're trying to find the axis about. Then you're going to go up to the parallel centroidal axis of the shape you're looking at. All right, so the parallel axis here would be this x-axis going through the centroid of this rectangle. You need to find the distance between these two axes. All right, so this was 15 millimeters, so this distance was 7.5, and the y bar is measured from the very top all the way down. So you take the y bar minus 7.5 to give you dy. Okay. Now we're going to take the area, multiply it by dy squared. That's going to give you 4.86 times 10 to the 7th. And then we need the I bar. This is what you're going to do, or when you're going to use the table. So we're going to use the table for the rectangle. And remember, the bar indicates centroid. So we want to find the moment of inertia about this x-axis going through the centroid of this shape. Right. So actually, let's get rid of this prime. I don't want to put that there. I think it's going to be confusing. So let's get rid of that. Now, if we look here, here's our rectangle. Notice it's got an x-axis going through the centroid. So we want this equation right here. So the 1/12 base times height cubed. Now you just plug in your values. That's going to give us 1/12 times 150 times 1 times 15. Cube that. That gives you 42,187.5. All right. Units for this is millimeters to the fourth, by the way. Same for this, millimeters to the fourth. Now we're done with this region. Now we're going to go to the next one. So now we've got this vertical rectangle here. All right, and this length is 150 now, and this width here is 15. So now we've got that. Now, easy to find the area. These are the same dimensions we had up here, so we know it's 2250 again. Now we need to find dy. So remember, we got to find the centroid of this shape, and then we want to find the distance between the x-axis going through this centroid and our x prime axis. That's what dy is. Okay, so if we come back up here, let's look. The centroid is going to be in the center. So if this is 150, when we go down 75, we'll have the centroid of this rectangle like that. That means we need to find that distance. Okay? So now we have that. Now what would that give us? You should notice that we're going to have the y bar, so we'll have the 154.4, and then we need to subtract this distance here. So this is going to be 15 plus 75. So we're going to have 154.4 minus 15 plus 75. All right, and that'll give us the distance between these two parallel axes. And that gives you 64.4. Now multiply this times this squared. And what do we get? We get 9.33 times 10 to the 6th. Now we have to find I bar. Now remember, this is the moment of inertia about this axis for this region. Okay, so the x-axis going through the centroid. So now, come back over here, and here's our equation. We're going to have 1/12 base times height cubed again, because that's the x-axis. There's our equation for the moment of inertia going through that, going about that x-axis. So let's write that down, plug in our numbers. We'll have 1/12. Now our base is 15, height is 150, cube that. You end up with 4.22 times 10 to the 6th. So now we got that. Last region is this circle. So let's look at the circle. That radius is 50. We can find the area, it's just pi r squared. So we'll have pi times 50 squared. That is 7,853.98. Now you have to find dy. So for this one, if we look back up here, we need to find the centroid of this circle, which is obviously right in the center. And we want to draw an x-axis through that because we want one that's parallel to x prime. Now the distance we want is that distance right there. Okay, so now with that, what do we think we get? Now let's look. We're going to go from here down to here, so I need to know this distance right here. And I just noticed when I look at this dashed line here should be all the way down to the bottom there. Okay, so this whole length is 150. Now let's find this distance here first. We need that, and then we can add it to that 50 for the radius here. So this distance right here, if this whole thing is 150 and this is the 154.4, and we've got this 15, that means we're going to have 165, that's the length from here to here, minus the 154.4. Y'all couldn't see it. So 165 is from here down to here because we have the 15 plus the 150. So go from here to here, 165, and then we'll subtract the 154.4. So this distance here is 10.6. All right, so that distance is 10.6. Now I also need this distance here, which is just this radius. All right, so that's going to give you 50. So we're going to have 10.6 plus 50. That's 60.6. All right. And this one you don't really need to worry about if it's positive or negative because you're going to square it anyways. So it doesn't matter if it's above or below the line. You don't have to worry about it because the sign's not going to matter anyways. Now we're going to multiply this times this squared. And once you do that, we get 2.88 times 10 to the 7th. And now we need to get the x bar, or I bar, about the x-axis. So again, you're going to locate your centroid of your circle. You want to find the moment of inertia about this x-axis, that horizontal axis going through the center of the circle. So go to your table. Here's the x-axis. So you're going to have 1/4 pi r to the 4th. That's the equation you're going to use. So we have that. Radius is 50. And that'll give you 4.91 times 10 to the 6th. Now we're done with all the hard stuff. Okay, so the hardest part for students is this one, this dy column, and then this one over here. So once you get past those two, you'll be all right. So now let's go ahead. We need to sum up everything. So remember, we need the I bar, we've got A, and then the dy. Okay. All right, actually we don't need to sum up area because we already got what we need over here. I'm underlining the wrong thing here. Let's do these two. Sum up the A dy squared. You get 8.67 times 10 to the 7th. And then we're going to sum up the I bar column. That gives you 9.17 times 10 to the 6th. Now we're ready to put it in our equation. So Ix prime is going to be 9.17 times 10 to the 6th plus 8.67 times 10 to the 7th, and that gives you 9.59 times 10 to the 7th, and that's millimeters to the 4th. Okay, so that's going to be your moment of inertia about that x prime axis. So it just kind of tells you the resistance to rotation about this x-axis here. Right, so imagine this thing kind of flipping around that x-axis like that. Okay, so that's how you do that one. So we'll do one more of these in the next video to give you another example.